All right, guys. So for today, part 2 of your notes is natural logarithms. Do you remember we talked about E the other day? Look on your calculator. Where was E located? Above which button? LN. Okay. LN stands for natural logarithm. Natural log. Okay. So the function y equals e to the x power has an inverse called the natural logarithmic function. You're like, what the heck is all of that, right? So if y equals e to the x, then its inverse, or its opposite, is y equals log base e to the x, which is natural log of x. So in other words, as mathematicians, we like to be lazy, right? If I can press fewer buttons, if I can do less work, I'm going to do that. So instead of me writing log base e, which we know e, is that a variable or a number? It is a number, right? 2 point something. So yeah, some of you know more digits of it. So instead of writing this e number down here, we've actually created a button on the calculator that will always do that process for me, and it's the natural log button. Makes sense. The opposite of it, if you look right above it, is your e to whatever power button. Right, just like on the, hold on, I'm going to say this wrong. On your x squared button, what's right above the x squared? Square root. What do we know about x squared and square roots? They cancel each other out. So same idea. The fact that your button on your calculator has ln, and then right above it is e to some power, they're opposites of each other. They cancel each other out. Okay. Now, if we were going to have time to get into solving in the next section, that is a huge thing to know in solving, trying to get rid of things when you're solving stuff. For us, the properties that we're working on yesterday and today, they don't mean as much to you because we're not going to have time to get to solving. But those of you that are going to be taking pre-calc, either here at Penna or when you go to college or whatever else, you're going to need to know these properties because you will deal with logs quite a bit in pre-calc. Okay? All right. So, but are they different? If I did like log of 3 and natural log of 3, are they actually different from each other? Grab your calculator. Do me a favor. Type in log 3 and hit equals. So if I just hit log of 3, what base is the calculator doing? Base 10. Okay, so log of 3 gives me what, 0.47712, blah, 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 bunch of numbers. What about natural log of 3? Is it different? Yeah. Natural log is like 1.0986, blah, blah, blah. Very different. Okay, so I don't want you to think they're the same buttons. Now, let me explain again, why are they different? Your calculator just did log base 10 of 3. So your calculator is figuring out for you, if I flip this into exponential form, it's figuring out 10 to what power would equal 3. That's what, when you type log of 3 in, what we just did, your calculator's figuring out 10 to what power is 3, because its base number is a 10. Right? That's what your calculator just solved for you. Right, that's what the calculator does when you're using those log buttons. Instead of you doing them mentally and like loopy-swoopy and you're thinking through like, okay, it's negative, so I know it's to the bottom, and like you're doing all that stuff, your calculator does it for you. Hold that thought. By the end of today, no, your calculator can do it for you, and I will teach you how. Okay. Natural log of 3. Natural log is log base e of 3. So in this case, when you're typing that in, your calculator is going e to what power equals 3. Do we see the difference between the two buttons? If I just hit log, it's saying 10 to what power equals 3. If I hit natural log, that's log base e. It's answering e to what power equals 3. So that's why it's different. It's using a different base for your log feature. Does that make sense? Okay? They are different. All right, so let's just get a little calculator practice. Just use your calculator to evaluate each logarithm, round to 4 decimal places. Just getting some button practice, okay? So natural log of 2. All right, round to 4 decimal places. So what do we get? 0.4 0.6931. Good. Natural log of 0.3. 1.2040 because it was 397. That 7's going to round the 9 up, which rounds it up to like 40 instead of 39. Be careful of your rounding properties. What about natural log of -1? No solution. It's non-real. For our purposes, it's no solution. Yeah. And then natural log of 1 plus the square root of 2. Good. 0.8814. All right, so are we comfortable with where the natural log button is? Yes. You literally type it in exactly like this. Yeah, so you literally type it in. It looks just like that in your calculator. Yeah. Natural log of 2, you got what? 0.6931. What the heck is going on with your calculator? Let's see. There we go. One of your settings was wrong. So remember that second plus 712 to reset your. Yeah, you probably should have done that. Yes, Jonas. Does what do exponents? No. There is a calculator that will do that for you, but no. You're not allowed to use it on any standardized test, though. All right. So what is each expression written as a single natural logarithm? So those properties we worked on yesterday for logs, they also work on natural logs. Because what is natural log actually? It's log base E. So it really is a log. So it's going to use the same properties. We can just write ln though, just lazy mathematicians. We created a new button just because it gets used so much in the math world. Okay. So if I'm using my properties, the 2 in front implies what? It's an exponent that goes to what? Only the 15, because that's right attached to that log. So I'm going to have natural log of 15 squared. What's the minus? Divided by 75. Would you stop there? I can simplify that. Natural log, what is 15 squared? Okay, and then 225 divided by 75? Okay. Natural log of 3. Do I go any further or am I good? We're good. It's 23. All right. So using my properties, I'm going to write, if I'm writing it as a single natural log, I write it one time. Okay. So natural log of 7 plus means multiply. There's a number in front of it. There's an exponent there, so 5 squared. Stop there or keep going? Keep going. What's 5 squared? Stop there or keep going? What's 7 times 25? Stop there or keep going? Stop there. Again, natural log is asking you e to what power equals 175? Heck if I know. You know, a lot of times you have variables or it stays a fraction or whatever. And that's fine. Just go as far as you can. Hopefully you recognize I can do 5 squared. And I can multiply 7 times 25, right? Yeah, so it's hard for me to be like, yes, you do this step, then this step, then this step. You can't. It just depends on the problem. Right? Still the same directions, writing as a single natural log. Now I threw some x's at you. All right, so the very first one there, what happens to the number in front? It's an exponent. So it's an exponent to what? Just the x. So that's going to be x cubed. Subtract means side. All right, there's another number in front. It goes as an exponent to what? The 2 and the x, right? So it's going to be 2 squared and x squared because it's in front of, that's both attached to that natural log. Keep going or stop? Keep going. So that's going to be the natural log of x cubed over 4x squared. Yeah, I can keep going again because I have x cubed on top and x squared on bottom. Yep, I'll have x over 4. Keep going or stop? Stop. Again, I realize you guys are probably grasping for like, why are we doing all these properties? If we had time for solving. I need like 1 more week with you guys. Then we can get into solving. And you can see how all of this ties together. No? You guys don't want to do it? You're that eager to get away from me? That hurts. Not just my class. Away from me and all this math. All right, why don't you guys try 25 on your own? All right, so 25. What did we do with the 3 in front? Moved it to the x. So I'm going to have natural log of x cubed. Plus sign means multiply. Number in front goes to the y, so that's going to be y squared. Plus sign means multiply, and it's just a 5. Do we like the way that's written? It looks kind of ugly, doesn't it? So natural log, how did you write it? There we go. Now, if you left it the way I had it written originally, totally fine. I'm not going to count off for that. It just looks weird. Right? Me personally, every time I see a plus, I'm like, great, multiply. So I like always draw a parenthesis so I know that it's going to be multiplied. It's just my thing. If you don't like that, if you like dots or whatever else, that's fine. That's just kind of my attack method. How are we feeling so far? Just a replay of yesterday's properties. All right, so the other new thing is what some of you have been waiting for. How do I get my calculator to do any log I want it to do? Right? Because the ones I was making you do and figure out on your own, some of you struggled. Okay? There is a formula that you can actually use to do this. Okay? It's called the change of base formula. It's not hard. It's actually pretty easy. All right? So you can use this anytime you want to do a log that does not have base 10. Yay! So any base can be used with the change of base formula, even base 10. So wow, that's typed really wrong. Use the calculator to evaluate logs with any base. That really needs changed. So in other words, as we look at this, okay, this is your general form, okay? So if I have log base a of x, meaning this a is something my calculator can't do normally, I can change the base to any base I want. If I want my calculator to do it, I want to change it to a base of 10. That way my calculator does it. Okay. So I can, and can I write just log if I want base 10? Because we're lazy. Okay, so I can take log of, you take the log of the big number first, and then you divide that by the log of what base you wanted. So down here, if I have log base 4 of 25, my calculator won't do that. But I can type in log of 25 divided by log of 4. Do we see it? The big number is on the top. Your base number is actually what becomes the number on the bottom. So in this case, technically, these are both base 10. That way my calculator will do them. I can change them to any base I want. And then I can just type that in, and my calculator will tell me what it is. So let's kind of, before we move on to the rest of the notes, let's kind of think back to something that we've already done. Like if I would ask you log base 3 of 9. Real quick, no calculator needed. What is this? It's 2. Okay? So again, this was, we've done this before. This is one I would give you, expect you to do in your head. This is asking 3 to what power equals 9? She told me it was 2. Great. So if I wanted to use my calculator, let's say I'm struggling, I'm doubting myself and my math abilities, I would type in log of 9 divided by log of 3. Because 9 is the big number, 3 is the base number. So this is the formula that lets you do this. Does that make sense? Yes. Now, granted on your calculators, when you hit log, it opens a parenthesis, right? So if I'm typing in 9, I have to close that before I hit divide by, and then I do the other log. Yeah, you're going to have to close it to say, hey, I'm done with that log. Yeah, so double check that. You have to close that parenthesis before you hit divide by. And make sure it works. This one, again, it should give you 2. If you want a nice, pretty answer that you can really check to make sure you know you're doing it right. Okay? But yeah, like this one, 4 to what power equals 25? Heck if I know, right? It's not going to work out pretty. Be 2.322 roughly. Like we have to round it at some point. That's going to roughly give you 25. Yay? So again, some of these are nice. We can figure out in our head. And I know you guys were in the beginning like, why do we need to throw a log onto this? I don't understand why log is used. Because not everything's pretty. If I want to know 4 to what power equals 25, I need a way to do that. And this allows me to do it. All right, so evaluate using the change of base formula with common logs. Round to 4 decimal places. So in other words, I'm asking you 2 to what power is 12? And you're like, I don't know, it's not pretty. So you type it in. So log of, so again, how we're doing this, we're doing log of 12 divided by log of 2. So log of 12, close your parenthesis, divided by log of 2. It's 3.5, what did I say, 4 decimal, 3.85850. It's going to round. Now, real quick before we get going, I know some of you really like to check your answers, right? You're like, I want to make sure I did it right, if it makes sense. So again, you can stop and think, 2 to what power equals 12? But if I type in, hold on, my calculator just went crazy on me. What did I hit? Okay, there we go. But if I would like check this and be like, okay, that means 2 to what power equals 12, and I found this. If I do 2 to this power, will I get exactly 12? Why not? We rounded. And you actually get 12.0003 something else. But I want you to be, some of you who check things might panic because it's not exact. It's because we rounded this. Since I rounded this, it's not going to be exactly 12. It is 12.000 to begin with, so it's really close. It's because I rounded. Does that make sense? So the next one, again, to figure this, it's asking 3 to what power equals 16? And I'm like, if I know, it's not pretty, right? So then I would do log of 16 divided by log of 3. Change the base formula. So log of 16, close your parenthesis, divided by log of 3. Good, so 2.5237. I watch my rounding there. I bet. So on 28, again, in your calculator, because again, it's asking 5 to what power equals 22. Don't know, it's not pretty. So log of 22 divided by log of 5. .9206. Good. Yes. That's a pretty fraction. You'd come up with that on your own guessing and checking, right? You'd come up with that guess and check, right? All right. So can you do any log then in your calculator? Yeah. Change your base formula lets you do that. Now, I will tell you the graphing calculator, if you find it, there is a spot in there to change it where you can change the base number in the graphing ones. It does do it. I know some of you have figured out where that's at. I don't teach you where that's at for the simple fact of you don't always have a graphing one, right? Sometimes you're at home, you have a scientific, you have your phone, right? Tip it sideways, you got log will show up on there. So you can do that on your phone using this formula. Yeah. If there's a number before the log, that would imply that it is an exponent. So I would put it back up here on there.
Oh, so would it be on both sides of like, or would it be like, or would it just be near the exponent of the...
Hold on, I want to make sure I know what you're asking. Like if I had a 3 log base 2 of 7, something like that?
Yeah.
And I'm asking you to solve that? Okay. Guys, good question. Couple things. He's asking, like, what does this mean if there was a number in front? Number in front implies exponent. So this would be log base 2 of 7 cubed. So I'd figure out what 7 cubed is. And then I would type in log, I don't even know what that is. I should probably figure it out. Thank you. So that's log base 2 of 343. So I would type in log of 343 divided by log of 2.
Okay.
Yeah. No, it only goes to whatever number is out here to it. So once I put it on there, then you don't even have to worry about it anymore. All right. Other questions? Okay.